Hi students, I'm ready to teach you lesson 90, which is called Systems of Three Equations. This is a one-topic lesson, and it's familiar and it's not too hard, but it's a little bit of a mind blower at first, because what we're going to do, looking at example 90.1 on page 374, is we're going to be working with systems of three equations, which means we're going to be taking something like this. Oh man, my eyes are so bad right now. X plus 2y plus z equals 4. I'm copying down the problem. Okay, if I made any mistakes in copying, I'll figure it out when I don't get the problem right, so we'll just go with this. I forgot my magnifying glass over at a friend's house, so I'm just improvising. All right, you guys, this is what's complicated. 3 variables, 3 equations. We have to simplify and solve to get values for x, y, and z. Just so you know, whenever we do systems of equations, you know how we've always talked about how it's the point on a graph where 2 lines cross. That's what a system of equation will tell you is the point where they cross. This is also true for a system of 3 equations, but now we're working in 3 dimensions. If you can imagine a cube and pretend it's like a graph of all of our points somehow, this would locate us like within, say there's a point within all 3 dimensions. This would locate us according to all 3 of those. So they're graphable, but it's very difficult to graph in 3 dimensions, so we usually just solve these using substitution and elimination. Here's what you need to know in order to solve these. This bent my mind when I first heard it. You can add our equations together over and over again in different ways to combine them and eliminate variables and eventually solve them. I never knew you could just keep adding equations together and changing them to eliminate things. Somehow that seemed like cheating to me when I first discovered it, but it works. So let me show you how it works. We're going to label these A, B, and C, just like John does, so that we can eliminate things with them. So the first thing that and I'm going to do it his way, but I will tell you right now, there's many ways to approach any one of these problems, and as long as you end up with, as long as you keep your numbers clean and end up with the right answer, there's no one right way. But what I'm going to do is I'm going to first start by comparing my first and second equations. I see x, y, z, I see x, y, z, I see numbers over here. What I immediately notice is that the z's offset each other. So for my first step, I'm going to choose to add A and B. Okay? And I'm just going to show you the steps in here to show you the steps I'm using for this problem, because of course there's no one way to do every single problem. You just keep adding things in beautiful ways. 2x minus y minus z. Okay, I like this because we don't have to do anything to get them to match up. Those cancel. I have 3x plus y equals 4, right? So we're going to give this equation a name since it's different than all the others. This is our new D equation. What we're going to do now, so that takes care of that. That's lovely. That's just how we want it. Now what we're going to do is we're going to go back up and look at our equations and see if there are, if we could take this third equation and add it to one of these first 2 to eliminate the same variable. And what you can see, I'm sure as well as I can, is look, if we combine B and C, we'll also eliminate our z's. So now we're going to add B and C. Again, this seems so weird to me that you can just be adding things, but it's true, you can. 2x minus y minus z equals 0. 2x minus 2y plus z equals 1. Hang on, I have to close the window. It's raining. The Malaysian rain is splashing on my feet. Okay, I'm back. I just went for a nice swim in the pool, And I'm so glad that it didn't rain while I was down there. Okay, so now we add b and c to get 4x minus 3y, these guys cancel, boom, equals 1. All right, we're going to name this equation E because it's completely new. Now, what we can do, and I'm going to squish it here, add D and E here, I've got some more paper, I'll do it like this. I'll slide this up. I'll put this here. Okay, so now we're going to add D and E. 3x plus 4, no, plus y equals 4. Sorry, I got excited there. And 4x minus 3y equals 1. All right, so you can see now we've got something that we're very used to doing. This is a very familiar sort of problem, and we're going to have to adjust it, aren't we? So I see our y's have got the signs going in opposite directions, so let's multiply all of this by 3. That will give us 9x plus 3y equals 12. And now we'll just kind of draw a line here so we know that, because we've rewritten that one there. So we will, I'll draw a line there so that we can see we've already dealt with that. And now we will actually add these two, and we'll get 13x. That all goes away. Oh my gosh, look what John did for us. He's so sweet, isn't he? Gosh, what a man. X equals 1. Ah, beautiful. Beautiful. Now we know that x equals 1, and we can use, so now let's solve for y. And we can use, sorry, I'm crooked. We can use one of these equations to solve for y. So let's see. How about this one? 3x plus y equals 4. If our x equals 1, then that's 3 times 1 plus y equals 4. Subtract 3, y equals 1. Also true, makes sense. And then our last step is to find one of our original equations so that we can solve for z as well. I'll choose that one. X plus 2y plus z equals 4. X is equal to 1. Y is equal to 1. So I'm just substituting that in quickly and easily. 1 plus 2 plus z equals 4. This is equal to 3, so I'm going to subtract 3 from both sides. Z equals 1. That's how it's done, you guys. Again, they're a little bit complicated. They blow your mind at first. So try example 90.2. and see if you can follow along his step-by-step. These are also really good problems to practice working when you do your homework. Practice them with your study guide right there and use the same strategy he's using so you can get a feel for it. And then after you get better, you'll be able to come up with your own strategy. So don't feel like it's cheating to look in the book and see the process they're using of combining the equations like we did here, A and B, and then B and C, and then combining our two new ones. It's not cheating to copy that process because you're just learning how to manipulate all the spaces, and you know what? That's how you learn. All right, good luck. Lesson 90. Talk to you next time.